Hello guys, I hope everybody is safe in your houses. So this is our first video lecture, and this is where we solve problems on infinite line charges. Okay, so I hope you have gone through the material which I posted in the group yesterday. So if you have gone through that, and if you know the formula to calculate the electric field intensity at a point due to an infinite line charge, we'll be able to solve this problem. Okay, so this is problem of 7, which is there in your study material which I posted yesterday in the electrostatics section of it. Okay, now let us go through the problem. So it says that there are two identical uniform infinite line charges which are parallel to the x-axis located at z equal to 0, y equal to -2, and z equal to 0 and y equal to 4. Now we are asked to calculate the electric field intensity at points P of 4, 1, 3, and the line charge density is 5 nanocoulomb per meter. It is given in the question. So now how do we go about this? So it is mentioned in the problem that I think the x-axis is missing, so you please write x here. Okay, so since they say that this is lying, the two infinite line charges are lying parallel to the x-axis, we will be neglecting the x coordinate while calculating the distance vectors, or for whatever calculations we are doing in this problem. Okay, so I've written the diagram here. You can see that we have the x, y and z axis, and these are the two infinite line charges which are located with the coordinates which is given. It is z equal to 0 and y equal to -2, and here I have line charge B with z equal to 0 and y equal to 4. Okay, so this is line charge A and this is line charge B, both of which are uniform infinite line charges. Okay, so we are asked to calculate the electric field intensity at this point P given by 4, 1, 3. So in the very first step we have to calculate the distance vector from line charge A and line charge B. So RAP happens to be the distance vector from line charge A to point P. So I calculate RAP as RP minus RA. Fine, it is 1 plus 2 AY cap plus 3 minus 0 AZ cap. So you know how to calculate distance vectors, you can do that, and after you calculate the distance vector you have to calculate the magnitude of the distance vector, and in this case it happens to be root 18. And once you know that, you'll be able to calculate the unit vector AAP cap. Okay, how do you calculate that? It is RAP, vector RAP divided by magnitude of vector RAP. So that is found to be 3 AY cap plus 3 AZ cap by root 18. So similarly you calculate RBP, which is nothing but my distance vector, which is the distance vector RBP. It is nothing but the distance between the line charge B and the point P. Okay, so this is given by RP minus RB. You know how to calculate this. Similarly, I've calculated the magnitude of RBP, and I've also calculated the unit vector A cap BP or ABP cap. I've calculated this. Now I know what are the unit vectors, the distance vectors now. The next step is to calculate the electric field intensity at this point, the electric field intensity at this point P due to infinite line charge A and infinite line charge B, and then add them up. So that is what I have done here. I have calculated the electric field intensity due to the line charge A, and then E2 is the electric field intensity due to line charge B. The formula, you know that it is rho L into A AP cap divided by 2 pi epsilon naught RAP. You substitute everything for E1 and similarly for E2. You know the line charge density, it is given, it is 20 nanocoulomb. So I've just put that, I've substituted everything. So ultimately I have to get this E, which is nothing but the sum of these two individual electric field intensity. So that happens to be finally 29.96 AZ cap. So I want you to calculate this and you'll be able to get this. The approach, I hope it is